Hey Chem Kids, Campbell here. In this video, we're going to learn how to calculate KEQ given concentrations, or how to calculate a concentration of a reactant or product if we know the KEQ. So just a little review. Remember in our last video when we wrote our equilibrium expressions, it was always the product concentration on top. We divided by our reaction concentrations, those were on the bottom, and they were always raised to the power of their coefficient. So for example, this was one of the reactions we did, and when we wrote the equilibrium expression, we put the product on top raised to the power of the coefficient, divided by the concentration of the reactants on the bottom. So again, raised to the power of their coefficient. And remember that this is a multiplication. So when we have two reactants or two products or three or four or however many we have, we multiply those together, not add. So not add. And so that's going to be important because now we're going to start doing the math. All right, so let's talk about the steps first. So remember, because we have that coefficient that becomes the power in our calculation, it's important that you balance all reactions. So always make sure it's balanced, and if it's not, make sure you balance it. Then you're going to write your KEQ expression. You cannot skip this step. This is very important. Then the concentrations, remember those brackets indicate concentration. The concentrations need to be in molarity, which remember is moles over liters. Now, in this class, you won't have to worry about that. We give them to you in molarity, but just from a future standpoint, it always has to be molarity or moles divided by liters. Then you're going to match the concentrations that you are given. So the numbers you're given in the problem, you're going to match those to your KEQ expression, and then you're just going to do math. All right, let's try a couple. So here is a reaction of nitrogen gas with hydrogen gas to produce ammonia. And so notice I got all these words, blah, 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 blah. Remember in chem, I always tell you, just find the numbers, the units, and what they're associated with. So don't worry about the temperature, right? There's no temperature in a KEQ expression, so that's just a miscellaneous number. But step one, remember, is to balance the reaction. So let's take a look at this reaction. I see I have two nitrogens here, but I only have one here. So that means I'm going to need to put a 2 in front there. Oh, it's kind of hard to see on that background, isn't it? When I do that, now I've made 2 times 3 or 6 hydrogens, but I only have 2 over here. So how do I make that 6? I put a 3 in front. All right, now I have 2 nitrogens, 6 hydrogens, 6 hydrogens. Cool. So now we can go and write our KEQ expression. So KEQ is equal to the concentration of the product. So that's our NH3 raised to the power of the coefficient, which is 2, divided by the concentrations of our reactants. So we have our nitrogen, N2. And again, we're going to multiply that. So if you want to put a little multiplication sign in there ahead of time, just so you don't forget, feel free to do that. You can just put a little cross or a little X. It's not a cross, it's an X in there. And then same thing with the hydrogen. Put in your little H2. And again, there's a power here. I know it's hard to see that coefficient, but so that means we're going to have to cube the value of our hydrogen concentration. All right, so now all we got to do is find those things in the numbers that represent those things in our reaction or our question, and then do math. All right, so we are trying to find the KEQ. So that is what I'm solving for. It's kind of like our X. NH3, so we go and we look and we see here our NH3 is this. So 0.1 squared. We're going to square that value. On the bottom, N2, so we got to find our N2. There it is. 0.25. This one's not squared, so that's cool. It's just 0.25. And then we got to find our hydrogen, which is right here. So 0.15, and we're going to cube that value. All right, so now it's just a matter of doing math, right? You just plug stuff into your calculator and you're good to go. I'll do kind of this little stepwise. So 0.1 squared is 0.01. 0.25 isn't squared, so that's cool. It stays the way it is. If we take 0.15 and we put it in our calculator and we cube it, we get 0.003375. All right, and then we're going to multiply those numbers together. oh boy, that's a small number, 0.008 4375, or 8.4375 times 10 to the negative fourth. So that takes care of that guy. And then, so all we got to do now to calculate our KEQ is we're going to take our 0.01 and we're going to divide by that 0.003084375. So if you do that in your calculator, you're going to get a number that is 11.85, depending on how much you round. Now, that is fine because I don't really grade you for significant figures in this class anymore. But if you look, how many significant figures should we have in our answer? Hopefully you said 2, because remember that zeros in front of a decimal don't count, or zeros in front don't count. So that means that if we really wanted to report this correctly, we would report it as 12, 2 significant figures, and that would be our KEQ for this reaction. Cool? All right, why don't you try this one? Balance your reaction, write your KEQ expression, plug your numbers in, and solve. So pause the video and then check and see if you got it right. So if you balance this reaction, right now when you first look at it, the sulfur looks fine, but you'll notice the oxygens are out of whack. So the only way to get the same number of oxygens is if we put a 3 here and a 2 here. That'll give us 6 oxygens. It's kind of like our last reaction. We had to do that with a hydrogen. But when we do that, that means now we have 2 sulfurs. So we're going to have to put a 2 there. So it should be 2S plus 3O2 yields 2SO3. Now write your KEQ expression. So your KEQ expression is the concentration of SO3 squared over the concentration of sulfur squared times the concentration of oxygen cubed. And then match numbers. So we're solving for KEQ again. So that's kind of like our X. For SO3, it's down on the bottom. So that's, that's 1.0 squared. Our S, sulfur, is 0.1 squared. And then our oxygen is 0.01 cubed. All right, so now you guys got to do some math. Just cubed and square those, and then so this on top now we have a 1, because 1 squared is just 1. On the bottom, when you square and cube that and then multiply them together, you get a really small number, 1 times 10 to the negative 8th. So when we do that division, we get 1.0 times 10 to the positive 8, right? When you have a negative exponent in the denominator, it becomes a positive when you divide. So if you do that in your calculator right, that's what you should get. All right, cool with calculating KEQ. See, it's key to write that expression. So balance your equation, write your expression, and then just plug numbers in and chug away on your calculator. All right, let's try another one. Wow, look at all these words. Again, ignore the words. Balance your reaction, write your KEQ expression, and then figure out what you're doing. So if I look at this reaction, we have CO plus Cl2 yields COCl2. Apparently that's called phosgene. Cool. If I look, I have 1 carbon, 1 carbon, 1 oxygen, 1 oxygen, 2 chlorines. Oh, it's already balanced. So now we just got to write our KEQ expression. Again, ignore the words. Just balance your equation, write your KEQ expression, and I apologize, I don't write very well on screens like this. And then we have our CO, our carbon monoxide, and our chlorine gas, and we don't have any exponents because there's no coefficients, so that's cool. Okay, so now let's do some matchy-matchy. What am I trying to find here? It says there's our chlorine. There's our carbon monoxide. Ooh, this time they gave us the KEQ, and we're solving for that. So that means that is going to be our X value. That's what we're solving for. So this time we have a KEQ. So we're going to write down 1.23 times 10 to the third is equal to, that's our X, right? We're solving for that. So I'm just going to put an X there to represent the concentration of COCl2. or phosgene. Find the CO, so that's just 0.012. We're going to multiply that by the concentration of our chlorine, which is 0.025. So let's bring this down here, times 10 to the third. That looks like a 6, doesn't it? And we multiply together our 0.012 and our 0.025, and that gives us 0.0003, or 3 times 10 to the negative fourth. So to solve for x, right, we multiply, oops, that's not a 0.03, I apologize. Oh, that's supposed to be a multiplication sign. Woo, hello. Times 10 to the negative fourth. We're going to multiply that on both sides. 3 times 10 to the negative fourth, because then we get it out of our denominator here. And so for x, we just multiply our 3 times 10 to the negative fourth times our 1.23 times 10 to the third. And when we do that, we get an answer of 0.369. Now remember, this is a concentration, so that means it has units. Big M is our unit. So that is the concentration of phosgene. Cool? All right, how about you try one of these? So here we have carbon dioxide reacting with hydrogen gas to produce carbon monoxide and water. So balance your equation, write your KEQ expression. This time, again, you have a KEQ. You're solving for the concentration of water. So see if you can get this correct. Pause the video and then check. All right, so if I look here, we have 1 carbon, 1 carbon. Carbon's cool. I have 2 oxygens. I have 1 plus 1 is 2 oxygens. I have 2 hydrogens, 2 hydrogens. So this is actually balanced. Well, that's pretty cool. All right, so KEQ is equal to, remember it's products, so CO. And then there's our water. No coefficient, so no powers. Divided by our reactants, so our CO2 and H2. So there's our equilibrium expression. And now let's just go matchy-matchy. And so we have a KEQ, so 0.803 is equal to, so let's find our CO. There's our CO. It is 0.47. Our water, oh, that's what we're trying to find. That's our X. And then on the bottom, our carbon dioxide is 0.53, and our hydrogen gas is just 1. All right, so we just got to do some math. If you multiply 0.53 times 1, that's just 0.53. So that means I'm going to multiply both sides by 0.53. And so I'm going to have 0.53 times 0.803 is equal to 0.47x. So if I multiply 0.53 times 0.83, I get 0.42559. So that's equal to 0.47x. Divide both sides by 0.47. And that's going to give us a concentration of water that is 0.9055. Now, significant figures again. If we want to do these in significant figures, how many significant figures should I have in my answer? That would be 2 again. So answering in proper significant figures, this would be 0.91. And again, units of big M for molar. Cool? Those are calculations. All right, so just a couple things, last things. What does this whole KEQ thing mean? KEQ tells you how many products you have versus reactants. So if you're going to have a KEQ greater than 1, you're going to have more products than reactants. If you have a KEQ less than 1, that means that your denominator is bigger, so you have more reactants. And if you have a KEQ equal to 1, right, that means your numerator and denominator are equal to each other. So you have an equal number of products and reactants at equilibrium. All right, how good? Do the problems next. See if you can get your calculations right.